Okay, today's September 26, 2011. We're doing lesson 1.5 and we're going to do some problem solving. If you guys remember from before, this is our theoretical model or skeleton model, or whatever we want to call it. This is a quadratic, and the a, h, and k represent all kinds of variables. So if you guys remember, first of all, we have been writing things in f at x form. So you can rewrite that like this if you like. And this is a alteration or a version of, this is called a parent function. F at x is equal to x squared. So f at x is equal to x squared is really like our original parabola. If you guys remember, I'm going to quickly show you how to graph that. Our vertex is at 0. We go over 1, up 1 on both sides. Then from the vertex again, I go over 2, up 4. Because 2 squared is 4. And again, from 3, I go over up over 3, up 9. So this is a graph of our f at x is equal to x squared, our parent function. Okay? The reason I've given you this new function here, or in the f at x version, is because a, h, and k represent changes on the graph. And what we're going to be working on is having the original graph, like we do down here, and making movements to it. So first off, we know that h moves our graph left and right. K moves our graph up and down. And A deals with stretching and compressing. So let's say S and C. Okay? So anytime we have a value in the place of h, that means we're going to move this parabola all together. That's one. Oh, I wonder if I can do it in one shot. Go like that. It won't quite work. Oh, well. So we're going to use an example of this. Now we've talked about movements of just h, just k, and just a. And we're talking about putting them all together also, which we've done once or twice before. Let's say we have the function f at x is equal to negative 2 x plus 4 minus 3. Okay? So first off, I have to recognize which of these numbers represent the letters we have above. So first off, our negative 2 represents our a. So we know our function is going to be stretched. Our positive 4 represents our h. So we know it's going to be shifted either left or right. That's right, to the left. And finally, negative 3 represents our k. So we know the function is going to go up and down a certain amount. Good. The first thing I'm going to do is I'm going to deal with shifting it left and right and up and down. So we'll start with k because it's the most logical one. It makes sense. If k is a negative number, which direction do we go? Downwards. We go in a negative direction. So I'll put our green graph, since k was green. And what I'm going to do is I'm going to move from the vertex. So the vertex is at 0, 0. I'm going to move it down 1, 2, 3. Okay? And I can decide to move every point down 3 if you like. But it is in your benefit if you get used to drawing a quadratic, because we're spending 4 chapters on this stuff. So I want you guys to know how to make the original one. So if our vertex is here, if I have to make an original one, I go over 1 and up 1 from there. Always go from where our vertex is. Then I would go over 2, up 4 from that spot. And finally, if I went over 3, I'd go up 9 from there. If I were to go over 4, how many would I go up?
16.
16. 4 squared. We always square the number that we go up by. So this parabola is technically, let's try that again. It's technically the same shape. All that's happened is been shifted down 4 units. So k was negative 3, so we went down 3 units. Okay? That's our first movement. Now, because there's 2 other variables, that's not our final. What I'm going to do next is I'm going to deal with our h. So our h is going to be a movement from our new green one. H is positive 4, so it's counterintuitive. H is positive 4. Which direction do I move? Left. I go in a negative direction. H is the opposite idea of K. So I go in the negative direction 4 units. So again, I get my vertex from the green one, and we go over to the left 4. 1, 2, 3, 4. And again, I can move every single point over 4. It's easier if you just know how to recreate the graph, especially when it comes to A. Okay? So again, I go over 1, up 1, over 2, up 4, over 3, up 9. So again, same shape as our original black graph and our other green graph. Only difference has been shifted down 3 units, and now it's been shifted to the left 4 units. So now we're at the blue parabola. Finally, last thing we need to deal with is our A. A is negative 2. So there's actually 2 changes we're going to have to make because it's negative 2. First of all, because A is negative, is this parabola still going to open upwards?
No, it's opening downward.
Yes, it's going to flip. So I'm going to flip exactly where the vertex is. Okay? So we're going to turn it downwards. It's no longer going to open upwards. So just to give you an idea, that's going to look something like this. Okay? It's going to be heading downwards because A was a negative number. The other thing is A is 2. So because the absolute value of the number 2 is greater than 1, is it going to be stretched or compressed? Stretched. We're going to pull it, so it's going to get thinner. Yeah, so anytime the absolute value of the number is a larger value than 1, we're stretching it. Think of stretching as getting thinner. Okay? This thing is getting thinner. So, in order to draw that, our vertex is still going to be at the same spot because A doesn't change the vertex. Okay? And normally when I draw our original 1, I go over 1, and because it's going downwards, I'd go down 1. But in this case, because A is greater than 1, I take that value, which is 2, and I have to multiply down by that. So the idea is, normally we go over 1, down 1, over 1, down 1. Because it's the number 2, instead of going down 2, instead of going down 1, I multiply that number by 2. So I go over 1, down 2. That would be 1 times 2. So it's at negative 5. So, in our next value, this is where it's going to start to make a little more sense. Normally we go over 2, and then I would go down how many? 4. I would square it. But because A was 2, I have to multiply that value 4 by the number 2. So how many would I go down now? 8, that's right. So I go over 2, down 8. What number am I at? 3 here? So I'd actually off the graph by 1.
You don't multiply the first number, you don't have to multiply the second.
Yeah, we don't multiply how many we move left and right from the vertex. We're just going with the up and down. Okay?
So be at 11.
So be at 11, exactly. So our final vertex, our final graph is a thinner version facing downwards, and it's been shifted 3 units down and 4 units to the left. Now, I have done all 4 steps. Okay? We started with the black graph, went to the green one, to the blue one, and then to the red one. You do not have to draw all of them. In fact, you don't even have to draw the original one. The only real one I'm looking for is the final one, which I did in the color red. That's the parabola I'm looking for. That would be this shift here. Okay? But if it is beneficial to you, and personally I always think it's beneficial to draw the original one, go right ahead. If you draw 4 different graphs, I don't care. Just tell me which one is your final graph. Okay? So what I would do if I was doing this on a test or something and I needed to draw 4, I would say final graph or final parabola. And I just put an arrow to it. That's the one. Okay? I made 3 different movements from the original one to that. We'll go over another example. Okay, so let's go recap what we've done. I drew the original graph. We discovered our K value was negative 3. So I shifted the entire graph down 3 units. Okay? Then from there, which is our green graph now, I dealt with my K. So this is already dealt with in terms of a graph. I don't have to do anything else with it. Next was our h. Our h was positive 4. Now, h is counterintuitive. So if it's positive, I actually go in a negative direction. So I shifted it 4 units to the left. I went from the green graph to the blue graph. So far I've gone down 3 and to the left 4. So now I've dealt with h and k. Done both of those. The only other variable left is our negative 2. So right now, imagine we're on the blue parabola. Because a is negative, I have to face it downwards. So this one is opening upwards. I have to make sure it opens downwards because it is a negative number. The hard part about this is how to actually graph a stretch. Okay? Now remember I told you original, we go over 1, and then I square that number. So I go over 1, 1 squared is 1. So I go up 1. I go over 2, I square that number. 2 squared is 4, so I go up 4. If I were to go over 6 units, how many would I go up? 36. I square that number. The only thing that's going to change, depending on our a value, is the amount we go up. We're always going to move 1 to the left and 1 to the right, 2 to the left, 2 to the right, 3 to the left, 3 to the right. The amount we go up will change depending on a's value. So because a's unit value is 2, I always multiply the amount I go up by the number 2. Okay? So kind of think of it as we would do x squared times 2. Right? I go over 1, I square that number. 1 times 1 is 1. And then I multiply that number by the number 2. So I go over 2 units. So, with that being said, here's our vertex. I go over 1. Normally I go down 1. But because a is 2, 1 times 2 is 2. So I go over 1, down 2 units. So there's one of my points. Double 36, whatever that ends up being.
No, not squared.
Okay. I do the same on the other side. I go over 1. And normally we go down 1, but 1 times 2 again is 2. So I go down 2 units. So here's my next point. So these are our 2 points in the red graph. The next thing we do is normally I go over 2 units. So I go over 2. Usually 2 squared is 4. But because a is 2, I take that number 4 and I multiply it by 2. So now I'm going down 8 units. So I go over 1, 2, and then down 1, 2, 3, 5, 6, 7, 8. Yeah, you take the final number and multiply.
The next one would be 9 times 2.
Yeah, the next one would be 9 times 2. So if I were to go over 3, 3 squared is 9. Because a is 2, we multiply 9 times 2. I would actually have to go down 18 units. Now clearly my graph isn't large enough for that, but that's where it really starts to get exaggerated. You really can tell that it's a much thinner parabola. Okay, 1C from the work I just gave you guys. Again, I'm going to start by putting out our theoretical model. In other words, what I mean is f of x is equal to a times x minus h squared plus k. This way I can figure out which variables are actually in this question. So first of all, is there a value for a? What is it? 1/3. So a is equal to 1/3. So right away that tells me it's going to be compressed. It's going to be a fatter parabola. And because it's positive, it's opening upwards. Good. How about h? What's the value of h? 0. That's right. There is no bracket in here. So h is 0. In other words, I don't move left or right. Okay? And what about our value for k? -3. So k is equal to -3. So before I start making these movements on the parabola, I'm going to draw the original one. Vertex is at 0. Over 1, up 1. Over 2, up 4. Over 3, up 9. So we have our original parabola. Next I'm going to deal with specifically the k. It's usually the easier ones to work with. So k is -3, just like our question before. So our entire parabola, our vertex goes down 3, and I'm just going to redraw the parabola from there. Over 1, up 1, over 2, up 4, and over 3, up 9. So again, parabola has not been stretched or compressed yet. All that's happened is it's moved down 3 units from where it originally was. Here's the tough part, the A. A is a value less than 1, so that means this is going to be compressed. So normally we go over 1, up 1, but because A is equal to a third, what is 1 times 1/3?
1/3.
1/3. So I go over 1, and I only go up a third of 1. So that would be roughly here.
That's so small.
Over 1, up a third. What about for 2? Normally we go over 2 and up how much? 4. But A is a third, so I need to multiply 4 times 1/3. What will I get?
4 over 3.
4 over 3, which is 1 and 1/3. So I go over 2 and up 1 and 1/3. We got to know your fraction rules for this stuff. What about for 3? Normally I go over 3, up how many? 9. Because A is a third, 9 times 1/3 would be 9 over 3, which is what value? 3. So I go over 3, up 3. 1, 2, 3. So if you guys notice, this parabola is fatter or compressed compared to the green version. And I could keep going for more and more values. Okay, question 3I. They've given you a graph, and they want you to match it to a function of a parabola. Okay? So, what I'm actually going to do is I'm going to show you how to create the function. So instead of guessing. If you guys remember, f at x is equal to squared plus f at x is equal to a times x minus h squared plus k. Now, here's going to be a hint for a vertex. Your h and k value will tell you exactly where the vertex of a function is going to be. So in this question, they've given us a coordinate. The coordinate is -4 and 3.
Sir, wouldn't it be 4?
The other one is -3 and 1. Okay, so they've given us a vertex. The vertex point is at -4 and 3. So I can already figure out what my h and k are going to be in this equation. Our k value is going to be whatever the y value is. It'll be exactly the same number. Okay, that will be our k value. So because y is 3, our k is going to be what number? +3. Our h is going to be the opposite sign of the x value of the vertex. So if x is -4, what is our h going to be? +4. So we already have that part of the equation. F at x is going to be x plus 4 squared plus 3. Next we're looking for a. This is where it becomes a little trickier. Okay? If you look at this, technically it's gone over 1 and down 2. Some of you might already be able to figure out exactly what a is going to be from looking at this. I'm going to show you mathematically how you can solve this, okay? We're going to leave a in there. And I'm going to substitute y in for f at x because it's a graph. So our new value is going to be y is equal to a x plus 4 squared plus 3. I'm going to rewrite it at the bottom again. So we had y was equal to a x plus 4 squared plus 3. Okay? I need to find the a value. So I need a point other than the vertex. And I'm going to plug it into the equation to solve for a. They've given us -3 and 1. -3 would be my x, 1 would be my y. So here is a coordinate they gave us, -3 and 1. x and y. So I'm going to plug those in. My y value was 1. So for y, I put the number 1 in. I'm trying to solve for a. X is negative 3 plus 4 squared plus 3. So now the only variable left in the equation is a. So I'm going to be isolating for a. So 1 is equal to a, negative 3 plus 4. Yes. Squared plus 3. What is 1 squared? Okay, so 1 times a is 1a plus 3. 1a is just a plus 3. And I need to move the 3 to the other side of the equation. So 1 subtract 3 is equal to a. That's an a, not a 9. A is equal to negative 2. So when we go back up to our equation, let's see if that makes sense. First of all, our parabola is opening downwards, so should it be negative? Yeah, so we know that makes sense. And if I go over 1, I normally go down 1. But if I multiply that number by 2, I would go down 2. So the equation they are looking for is f at x is equal to negative 2, x plus 4 squared plus 3. That's how you reverse engineer an equation looking at a graph.